All right, today we're going to look at, start looking at section 3.8. We're just going to look at the first part of this lesson, and we're going to be talking about how to solve a system of linear equations and how we can solve linear and quadratic systems by using graphical and algebraic methods. So we're going to start with the method of substitution, and substitution is a method we have used in the past. So when you have a system where we have two equations, one that is nonlinear, one that is linear, we can use substitution as a method to solve. And the way we do that is we want to look at our linear equation in our nonlinear linear system and get one of the variables in the linear system by itself. Now, the variable that we want to isolate is going to be the variable that is not in the other equation have a quadratic term attached to it. So in this case, the x is the one that does not have a quadratic term attached to it, so we want to get the x by itself. So to get the x by itself, we're going to subtract a y off of both sides, and then we're going to divide both sides by -1. So x is y plus 1. So now we're going to take that, what x is equal to, and we're going to substitute it back into the first original equation. So this is going to be y plus 1 equals 2y squared plus 3y plus 1. All right, so now we have a quadratic equation with one variable. So what we're going to do now is we're going to isolate everything to one side. So we're going to subtract y off of both sides, and we're going to subtract a 1 off of both sides. And so we get 0 equals 2y squared plus 2y, because the 1 and the -1 cancel out. All right, from here we can factor, we can look for a greatest common factor. We can pull a 2y out of both of those, and that leaves us with a y plus 1. So 0 is equal to 2y times y plus 1, and now we can use our zero product property. Our zero product property says that when you have two things that multiply together to equal 0, one of them must be 0. So if I have 2y times y plus 1 equals 0, that means either 2y is equal to 0 or y plus 1 equals 0. And if 2y equals 0, then y equals 0. And if y plus 1 equals 0, then y is equal to -1. So what we have now are the two y values of the solutions of this system. And we have two solutions, so we're going to run each of those through one of our original equations. So if I have x equals 2 times 0 squared plus 3 times 0 plus 1. So if I run 0 through my original equation, I get x is equal to 1. So that point would be, that solution would be 1, 0. And then the other equation would be x equals 2 times -1 squared plus 3 times -1 plus 1. So -1 squared is 1, 2 times 1 is 2, 3 times -1 is -3. 2 minus 3 is -1, -1 plus 1 is 0. So that one is 0, -1. All right, so common mistake is, hey, I found my y's first, so I list that first in my ordered pair. Remember, the x term has to go first in the ordered pair. That's a very common mistake that people will put them in the ordered pair the order that they solved them. If you solve for x first, x has to go first in the ordered pair. All right, so those are our points, 1, 0, and 0, -1. All right, now, if we're going to use elimination, we have done elimination in a linear system before. Again, we want to get our variables to drop out, but in order to do that, we have to have all the variables on one side of the equal sign. So we need to make this x squared minus y equals 5, and -x plus y equals 7. So now, if you look, I have an opposite pair of the -y and the y. So I can go ahead and add these together. Now, when I add these together, x squared plus -x, that's just going to be x squared minus x. Those are not like terms. I can't combine them, so I got to leave them like that. The y's drop out, and that's equal to 12. Now, x squared minus x equals 12. I want to solve that, so I need to get it equal to 0. X squared minus x minus 12 equals 0. So from here, I can solve in any of the ways I want. I always default to factoring first. So I'm going to start with that, negative 12 and negative 1. So we'll see if it factors. Multiplies equal negative 12, adds equal negative 1. Well, that is positive 3 and negative 4. So x plus 3 and x minus 4. So x plus 3 times x minus 4 equals 0. Two things multiply together to equal 0. One of them has to be 0. That's my zero product property. So x is negative 3 and x is 4. So those are my two x values. All right. So negative 3 squared equals y plus 5. Negative 3 squared is 9. Oh, y plus 5. So if I subtract 5 from both sides, I get 4. Y is equal to 4 if x is negative 3. So negative 3 comma 4 is one of the solutions. Then if I run 4 through that same function, get 4 squared equals y plus 5. So that's 16 equals y plus 5. Subtract 5 from both sides, I get y is 11. So the other solution is 4 comma 11. There you go. That's our two solutions for that system by solving using elimination. Next we have, I will admit I got a bigger graph for this one because it's going to require a bigger graph. But we're going to graph this system, a linear and nonlinear. The first thing I'm going to do is I'm going to graph the linear. That's really simple to graph a linear equation. Remember, we just put a point at our x-intercept, our y-intercept, and then we use our slope. So we go up 4 and to the right 1. Then we can go down 4 and to the left 1. Okay, so there we go. That is our linear. That's the y equals 4x plus 1. Now we're going to graph our parabola. So the first thing we do is find our vertex. Negative b over 2a, so 2 over 2 times 1, which is 2. So that's going to be 1. So our axis of symmetry for our parabola is 1. And if I run 1 through the function, 1 squared minus 2 times 1 plus 6, 1 minus 2 plus 6, 1 minus 2 is negative 1, negative 1 plus 6 is 5. So at 1, 5, we have a intercepting point, and, that's our vertex, and that does happen to be an intersecting point. It is on the parabola. Now, if we go to the right from there, and left, so if we put, let's see, 1, 5 in the middle of our table, pick some points to the left and the right. All right, if I run 0 through the function, that gives me my y-intercept, which I already know is 6. 3, if I run that through the function, 3 squared is 9, minus 2 times 3, so that's minus 6, so that's 3, plus 6, so that's 9. Let's see, 4 through the function, 16, negative 2 times 4 is negative 8, 16 minus 8 is 8, 8 plus 6 is 14. And that is going to be off our graph. So 3, 9, And 4, 14. Let's see. If I run 4 through the second function, 4 times 4 is 16 plus 1 is 17. So that's not going to work. All right. 5, if I run 5 through the function, sorry, these are off the graph, but let's see if it ever is going to catch up and intersect again. All right, so 5, the y value for the first function, 5 squared is 25, negative 2 times 5 is negative 10, so that's 15 plus 6 is 21, and 4 times 5 is 20, plus 1 is 21. So at an x value of 5, these would also cross at the y value of 21. So they would intercept again. So this does have two solutions. One of them is at 1, 5, 0, 1, 1, 5, 2, 9, maybe 3, 13. So, so we're looking here at where the y values match. That would be where the solutions are. So we're able to find it using the table n by graphing, even though this went off our graph technically. All right, so that is how we can solve by graphing. Anytime we graph, we can see the picture that a parabola, it's always going to look, if we have a parabola opening upward, if we have a line intersecting, there could be two solutions like that. There could be one solution where it just goes to the vertex. It's possible that it goes below the line, the parabola, and never touches. Have no real solutions. Those are all the possibilities for a system of linear, nonlinear. All right, so hope that is helpful for you. If you have any questions, please send me a Canvas message or shoot me an email, and I'll get back to you as soon as I can. Have a great day.